Data-centered architecture. In data-centered architecture, the data is centralized and accessed frequently by other components, which modify data. The main purpose of this style is to achieve integrality of data. Data-centered architecture consists of different components that communicate through shared data repositories. The components access a shared data structure and are relatively independent, in that they interact only through the data store. There are two types of components. A central data structure, data store, or data repository provides permanent data storage. It represents the current state. A data accessor or a collection of independent components that operate on the central data store, perform computations, and might put back the results. Interactions or communication between the data accessors is only through the data store. The data is the only means of communication among clients. The flow of control differentiates the architecture into two categories. Repository architecture style. Blackboard architecture style. Repository architecture style. In repository architecture style, the data store is passive and the clients, software components or agents, of the data store are active, which control the logic flow. The participating components check the data store for changes. The client sends a request to the system to perform actions, for example insert data. The computational processes are independent and triggered by incoming requests. If the types of transactions in an input stream trigger the selection of processes to execute, then it is a traditional database or repository architecture, or passive repository. This approach is widely used in DBMS, library information systems, the interface repository in Chorba, compilers and CASE, computer-aided software engineering environments. Blackboard architecture style. In Blackboard architecture style, the data store is active and its clients are passive. Therefore, the logical flow is determined by the current data status in data store. It has a Blackboard component, acting as a central data repository, and an internal representation is built and acted upon by different computational elements. A number of components that act independently on the standard data structure are stored on the Blackboard. In this style, the components interact only through the Blackboard. The data store alerts the clients whenever there is a data store change. The current state of the solution is stored in the Blackboard and processing is triggered by the state of the Blackboard. The system sends notifications known as triggers and data to the clients when changes occur in the data. This approach is found in specific AI and complex applications, such as speech recognition, image recognition, security system, business resource management systems, etc. If the current state of the central data structure is the main trigger of selecting processes to execute, the repository can be a Blackboard and this shared data source is an active agent. Difference with traditional database systems is that the invocation of computational elements in a Blackboard architecture is triggered by the current state of the Blackboard, not by external inputs. Parts of Blackboard model. The Blackboard model is usually presented with three major parts. Knowledge sources, KS. Knowledge sources, also known as listeners or subscribers, are distinct and independent units. They solve parts of a problem and aggregate partial results. Blackboard data structure. The problem-solving state data is organized into an application-dependent hierarchy. Knowledge sources make changes to the Blackboard that lead incrementally to a solution to the problem. Control. Control manages tasks and checks the work state. Thank you for watching today's video.